Hello, this is Robert Guderian. Today we're talking about sets and our continuation of data structures. Sets are very useful and something that we know about tangentially. If you've ever seen a Venn diagram of any persuasion, you've seen sets. And we often think in forms of sets, but maybe don't realize that we have. So you can see that I have two links here that'll bring us over to a whole bunch of information about sets. This first link is actually really good if you want something to look through to see some information about sets. They have some syntax that I'm not going to touch on here in different ways to make sets. I will always just use the set keyword, a built-in function to create sets. It's my favorite way to make it because I don't use them often enough to justify doing anything fancier than that. There's some also talk about built-in types. We will get back to this one in a moment because there's some nice keywords we can use with these because they are native. They're built into Python. They're a first order member where they're just available to us, just like dictionaries. But they're also very powerful tools that we can use. So let's make two sets. They are passed a sequence type or anything that you can iterate over. Lists are frequent for these, and it'll create two sets for us. One important thing about sets is that there is no duplicates. In a set, you can see that I have spam, 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 and eggs. And that set will only contain spam and eggs. The second one, bacon, eggs, toast, will have three items of bacon, eggs, and toast. And we can see these as Venn diagrams fairly easily, where we'll have one circle, we'll have another circle. So this one had just breakfast. And this was a normal breakfast. This one has spam, and eggs is shared between both of them. This one also had bacon and toast. So if you've ever seen a Venn diagram, anything that is in the middle is shared by both of these sets. So now we can do some set operations to see what happens. The set union is all of them. So that would be spam and eggs and bacon and toast. Absolutely everything. It is the union of both sets. The intersection is this middle part, which is just eggs. That is the only item that is shared between both of these sets. There's set subtraction, which will subtract one set from another, and that will take everything except what is in the intersection of the two. If these are two sets that have nothing in common, this operation will do nothing because there would be nothing inside of this intersection. So that would be just spam. Okay. I just changed my Microsoft password and that popped up that it's angry. Those are the key tools that we're going to use here. And if we flip over to our slides, we'll see that there is very simple methods. So that is a function attached to an object, because these are objects, as we've discussed before, where you're going to take breakfast, that was spam, 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 and eggs, and show me the intersection of these two items. And that will return a new set. So now there's three sets at play, which will be just the intersection, just that area that is overlapping will be returned as a set. The union is everything. Difference is the subtraction. And very nicely, we can use the in operator. We have used this with lists and with dictionaries. With lists, we can say item in some list, and it'll be true if this item is in the list and false otherwise. We can do this with dictionaries. We can ask if a key is inside of a dictionary, saying, is this key in my dictionary? It'll be true if it is, false if it's not. The exact same thing is true here. Is spam inside of my set? And in this case, is spam inside of a normal breakfast? No, of course not. Spam is weird and salty. There is more overloaded operators. That is a fancy term for these words like in and also subtract. I'm not going to test you on any of these. Know that sets exist. That is really key here. And know that there's a lot of really cool functions you can do. So greater than or less than exist, which is crazy to me, which are testing if something is a proper subset. This is not a set theory class. I took a class that had set theory. We talked about it for 2 weeks. I don't have time in this class to talk about it, but you can see that Python has these built in. I do care that length exists, that in exists, that not in exists, and those are good. Is subset is cool, but I'm not going to actually use that one. And there's all of these nice functions we can use to grab all of these very interesting pieces of data we can use now that we have sets. But for us, the keys are there's no duplicates inside of sets, and it has these really nice functions that will let us do simple set theory. And here we can see that there is more complex set theory, and we can maybe, if we're doing any set theory, if you see a problem and recognize it as set theory, Python might have solved that for you. Oh, I just clicked that. That's not what I wanted. There we go. There are some operations that are important. If we have a set, we can add and we can remove things. And let's actually take a look at that. We haven't programmed yet. I'm getting thirsty for programming. So I've created 3 sets here. And you can see that they are strings and got busted into all of these spaces. I forgot to put these into lists. I'm going to pause, and I'm going to break those into lists. I could have done that live. I decided to just be clever and use .split, which gives us a list. And then you can see over here that all of these have been broken into lists and then have been made into sets. You can see that it goes on and on, my friend, has on multiple times in it, but you'll see that our set, indeed, does not have it in there multiple times, as discussed. There is no duplicates in sets. That is not what sets are useful for. So there we go. We have 3 sets, and we can start doing math on them. This is the song that never ends. It goes on and on, my friend, are 2 sets that have no overlapping data. So if I said set 1, subtract set 2, I would get approximately the same set as I have in set 1. But if I have set 3, there is some overlap, and you can see that it'll remove any item that is in both sets. I'll make that a little bit bigger for you. So that's excellent. I can use intersection. So set 1 and set 2. Has nothing. There is no overlap in the data. Set 1 and set 3, this is that. I like that. That was accidental, but excellent. Fantastic CBC show if you're ever bored. Those are the common terms. And if I finally did a big union, set 1, dot union on set 2, you'll see that it's suddenly huge, and you can see it reshaped it because there's so much data there. So cool. We could add more data to any one of these. Set 1 dot add it. And now set 1 and set 2 have an intersection that it is now in both set 1 and set 2. So when I call intersection, it'll come up in both. I can also use dot remove, which will remove it. Set 1 dot remove it. And now there's no more intersection. They're very flexible and very kind data structures. The hardest thing here is to know when to apply it. pop up from time to time where you can actually use it, and it'll probably save you a whole bunch of code. But programming these from scratch isn't actually that hard. If you have a list, all you have to do is just to first of all, check if that item is already in your list, and if it is, you don't add it. Okay, doing a subtraction, you need to do some for loop stuff, and we'll probably do that in the lab because it's actually a really good exercise. Okay, so let's be literate. Let's read in 2 books and find out which words are in both. And actually, what words aren't in both. That might be just as interesting. So, we have some code for this, don't we? Of course we do. We did some work with book.py, which took Alice in Wonderland and then counted all the words. But these for loops are actually quite meaningful to us, aren't they? So we're opening up Alice in Wonderland. We're going to each line. We're breaking into words. Hey, that's what we want. We want every single different word inside of this big book. So instead of adding it to a dictionary, what I'm going to do is add it to a set. I'm going to name this book set. And I have my word. It's named word. I'm just going to name it first book is equal to a new set. And this set is initially empty. And every time I see a word, I'm going to say first book dot add my word. Okay, neat. I have a second book. It's actually a really good place for a function. We might come back and revisit this when we do functions. If not, actually ask me to do it because it's really compelling. Because copying and pasting code is stupid, and I'm not liking what I'm doing. On the book. I think that's next week. Set Frank N. Stein, which is the doctor, not the monster. But it is also a book that is on Project Gutenberg, and kind of neat. And I checked to make sure it was UTF-8. Okay, so the second book is a set, and we're going to go through this whole book. And if we're being good citizens, I'm going to be a good citizen for once. First book dot close. And I'll actually close my second book. You've heard the rant. This is Python. You don't have to. Those are functions. I just want to do it. Save. Now, all I have to do is, I'm going to call it diff, is first book. First of all, what data were we looking for? Intersect. Let's see what words are in Alice in Wonderland, but not in Frankenstein. So we're going to take Alice in Wonderland minus Frankenstein. That feels so weird. I love it. First book dot difference. I like using the functions. I think you can use the subtraction sign for this, but that freaks me out. Again, I don't use these enough that I'm comfortable with these overloaded operators, like using subtraction for this. And I'm just going to say print diff, which is going to be probably duff. Duffman. Boom. Oh, set has no, yeah, I want to close the book, not the set. There we go. I agree. The book is, I got the wrong one. Second. I'm actually terrible at copying and pasting. I think my meme is about copying and pasting code being an insecure programming practice. That's why you're going to copy and paste stuff and not think about it properly. And then you're going to absolutely ruin all your source code in front of 240 people. Boom. Notice how fast that was. My computer is fairly fast, but that's quick. So these are all the books that are in left and not in right. So words like Griffin. I'm not too surprised. And Pine-Apple is not in Frankenstein. Today you learned. If you're going to remember anything from this lecture, remember that Pine-Apple. It does not appear in Frankenstein. It still has all of the punctuation. I'm going to show you how to get rid of that later. Spoke fancy. One word. Interesting. Cool. So that's how you do it. Making sets, again, this becomes somewhat abstract. You don't know what you put in this set because you read an entire book. And that's interesting. I'm going to do this one more way because I feel like being crazy and I have a little bit of time. You can turn off if you're not interested in being cool. Do we need these for loops? Not really. We can read this whole thing as a string, this whole book in as a string, by using .read. And then we can use .split on the string that returns, and then put that into our set, and that would actually just be our set. This is hard mode. This is, if you can understand this, you're doing really well. Especially because I just ruined it. And this is now first book. First book is equal to the set of anything that comes out of that split, which is actually going to be a heck of a lot of data. And then we close it. And we don't need word count because we're not using it anymore. There we go. And we're going to do the same thing for Frankenstein. Second book is equal to the set of the book .read.split. I don't actually like piling up functions like this. I do want you to see it. Fast. Read book set. Read book set. Now I don't need this. I still want to close it because I want to be a good citizen. All of a sudden, this is turning into very few lines of code, isn't it? If I run it, I believe it ran faster and gave me the same result. So there is lots of different ways to solve the same problem in programming. That's something that I wanted to show you here. And that if you know your functions and tools, suddenly things might become very easy. So know what these set operations are. Well, we're going to play around with them in class. They're actually kind of neat, kind of interesting. We can do all of these things manually. There's nothing after this class, you'll be able to create a set. They probably won't be as fast as the sets that they use, but they're actually not that hard, which is very cool. So there's some more reading on sets. I believe that's the documentation again. And I hope you're having a good day.